All right, class, today we're talking about sine and cosines as waves. So we're going to take our unit circle, we're going to unravel it, we're going to plot these points and see what these things look like. Now, I cannot get both of these pictures on my screen, so I need you to have beside you your sine chart that you filled out a couple of sections ago. You had the unit circle where you put in all the values. You will need that beside you so you can look at what your values are to plot them. You'll also need a calculator, and let's go. All right, so we're going to talk about the sine graph. We're going to do variations of the sine graph, so how does it move? We're going to do the same thing with the cosine, and then we're going to do vertical shifts also. So we're moving these things. We're moving left, right. We're going to change the amplitude like a stretch and a compression, and we're going to reflect them. All those things we've done with all the other graphs, but now we're going to do it to a wave. All right, the first thing we're going to do is going to unravel the sine, and we're only going to worry about 4 main plots, and I wish I had a different graph here, but I do not. So the ones I want to worry about are actually on the axis. So your points that are on the X and Y axis only is where we're going to look. So when we go here, when we do that, we know that that occurs at a 90. There we go. So this is 90, which is pi over 2. Pi, next one you have is at 3 pi over 4, or your 270. I'm sorry, 3 pi over 2, and 2 pi. So those are the increments we want to look at. So your very first dot on your unit circle is, when you look at the, we're going to start with sine, which is the y value. So look at the y value of your point on the axis only is what you're looking at. So your very first dot on the y value is 0. So we plug a 0. Now you go to 90 degrees and the y value is 1. Now you go at pi, or 180, your y value is 0. 3 pi over 2, or 270, your y value is -1. 2 pi, it's 0. Now if you look here, we continue around the circle. We would start over. So if we're starting over, we're going another 90 degrees, and we would be at 1. When we got the 3 pi, that's like pi, we would be down to 0 again, and then this wave just continues forever. Now we're going to connect these dots in nice, smooth curves, and this is a sine wave. You can also go backwards. So here you would be at 0, you would go down to -1 if you went backwards. Whoops, I missed. And then back up to 0, then you would go back to 1 and down to 0, and you would continue on. So a wave goes forever. The part we're going to worry about is just one complete period or cycle. So when we start here at 0 and we end at 2 pi, we've gone around the circle once. So that's called a period, our periodic function, because it repeats every 2 pi. All right, now we're going to do things to this. We're going to shrink them and stretch them and all this stuff. But when we're graphing, we're going to worry about this first wave is what we're going to worry about, or the first complete wave. So now the domain, so remember the domain are the x values. Our x values go everywhere. I can go around that circle as many times as I want in the positive and negative function. Now, if you look at your sine wave, it oscillates between negative, whoops, should have been a bracket, my fault, between -1 and 1, because it can go up to 1 or down to -1, and it just continues to go back and forth. All right, there it is drawn out for you. A little bit better, prettier. So one cycle is 2 pi. It just continues to repeat. It goes up to 1, down to -1. Then we're going to worry about those 5 points. That's what I'm going to be grading. Okay, it's periodic because it repeats every 2 pi. Also, we know it's an odd function because when you plug in a -x, you get the negative sign of x. We've talked about that before. Okay, example, the sine of 90 is 1. The sign of -90, so when you go backwards, is -1. All right, let's go here. When we look at this, there's 5 main points. That's what we plotted, right? It was all the way around. It was the 90 degrees. While we started at 0. 1/4 of the period is how far we went, because when we did this, we started here. This is 1/4 of the way. So that's pi over 2. this here's 2/4 of the way, or 1/2. Well, 1/2 is pi. So you remember where you're at. Now we're 3/4 of the way, which is 3 pi over 2. And then we made our complete circle, which is 2 pi. All right, so there's 5 points because you start and end on the same spot. Okay, so our critical points are every 1/4 of the way. That gives us our maxes, our mins, and our roots is what we want to look at. All right, they move just like everything else we've ever talked about. We have an amplitude or a stretch. That's the number in front. So if it's positive, it goes the same way. If it's negative, it reflects over the x-axis. And this tells you how far up it goes. So it changes our range. So if this is a 2, it's going to go up to 2 and down to -2. It's called the amplitude. So we're going to start with stretch only. So stretch only means I still have the exact same function, just at different spots. I still start at 0, 0. I still go to pi over 2, but now instead of going at 1, I'm going to multiply by 2 and I'm at 2. Pi is still 0. 3 pi over 2 was -1, but times 2 is now -2. And 2 pi goes back to 0. So now my entire sine wave is in the same location, but it has stretched too. And it just disappeared. Okay, I hope you did okay with that. Here, let's put our parent graph in there just so you can see. So your original graph would have went like so. Would have started at 0, 0, went to 1, down to 0, down to -1, up to 0. When you do this, all you're doing is you're taking the y values times 2. And you got your new values. It's a stretch, or an amplitude is what they're called in sine and cosine. All right, this time, what is your amplitude? And I hope you're telling me 1/2. So now we have the same critical points. We know the 0, 0 is going to be the same. The pi is still going to be the same, 0, and the 2 pi is still going to be 0. Now at pi over 2, which is my max, and 3 pi over 2, which is our min, we're going to go up to 1/2 here and -1/2 here. That is hard to see with that in there. So it got very, very thin. It's a very soft wave. Like if you were at the beach, it would be barely rolling in. The higher they are, the stronger it would be hitting the rocks, right? All right, the next part we're going to talk about, so amplitude is how high it goes, or low. B is how many periods we have. So whatever number is in front here, we take 2 pi and divide it by it. And that will tell you when I get a full wave. All right, so it's the length of the new period. So let's go here. So like if there's a 2 in front, that means I have 2 waves in 2 pi is what it means. All right, one of these I had in here. Was it this one? Let me double check. Let me pause it. Okay, I don't like this problem right here. So I want you to cross that out. It doesn't do what I want it to do. I want you to make that 3 sine of 2x equals your y. All right, so now your amplitude is not 2, is 3. Now your period, you take 2 pi and you divide it by 2, so it's pi. That means in pi I get a full wave. Understood? So in 2 pi, I'm going to have 2 waves. I have taken my sine wave and pushed it together or shrunk it. Okay, where am I at? Here? Here it goes. All right, so now we got to find our new critical points. So our new critical points, if a wave is in pi, you take this number and you divide it by 4. So we get pi over 4. Now we add those. So we go to 0, pi over 4 plus pi over 4 is 2 pi's over 4, I'm sorry, or pi over 2. Add another 1/4. So now you've got 2 pi over 4 plus another pi over 4, and you get 3 pi over 4. Add another pi over 4, and you're at pi. So you have to end where my period is. I have to end at pi or something's wrong. And we always start at 0. So these are my critical points. Now I know a sine wave starts at 0, 0. Its middle point is 0, and then pi is 0. Those are my roots, remember? So these are the first 3 points we're going to put on our graph. So let's go to our graph. We have to draw these in now because we obviously don't have them. So I can put my force in. Okay, so at 0, 0, I have a point. At pi over 2, I have my 0. And at pi, I have my 0. There are my roots. Pi over 4, I know this is my max. So now my max is going to go up to 3 because that's my amplitude. 1 times 3. And this is my min, so it's going to go down to negative 3. So at pi over 4, we're at 3. At 3 pi over 4, I need more room. We need to be down to negative 3. And put your min. Okay, connect your wave. I only care about one cycle, so you can see how it squished together. It's oscillating faster is what that is, and it's going higher. It's going to 3 and down to negative 3, so it's getting to be a rougher wave. If you're looking at what's on the, hang on, there it goes. Okay, now let's see if you can do this. Negative 2 sine of 1/2 x. Okay, you're going to need 4 pi on this. Pause and give it a shot. And I hope you did well. You should have taken 2 pi divided by half and gotten 4 pi. Now you take 4 pi and divide it by 4 to find our critical points. So they're pi apart. So it's 0 pi, 2 pi, 3 pi, 4 pi. And we know that the first, the third, and the last are our zeros, are our roots of our function. And then we have to multiply 1 by negative 2. So this one here goes to negative 2, and then a negative 1 by negative 2 goes to 2. So this one here reflected and stretched. So we started at 0 at pi, 2 pi, and 4 pi. At pi, we're now down to negative 2, and at 3 pi, we're up to 2. I hope you did well. Sorry the graph wasn't big enough. All right, next on the list, we are going to do a phase shift. So now we're shifting it left and right. Remember when we used to have like x plus 2, and that would have moved at left 2? This is the same type of thing. So far we've done our amplitude and our reflection. We've done B, which is how often we have our cycle, like our period where it occurs. Now C is a shift. We can't do it quite as easily as this one because this B of x changes how far it shifts left and right. So to do this, we have to take x equals c over b. So like where we're starting, you take the c value, so it's actually the opposite of it, whatever it is, and divide it by b, and this will tell us how far we're shifting left and right. All right, so let's go here. So 3 is my amplitude, so remember that's how high up I'm going to go. My period, I take the 2 pi and divide it by 2. Again, nothing different. So I got pi, so my critical points are every pi over 4. So we've done that before. So we're going to start at 0, pi over 4, pi over 2, 3 pi over 4, and pi. So I've ended up where I'm supposed to. I've got my 5 points. Now my phase shift, I take the pi over 3 and divide it by 2. So pi over 3 divided by 2 is pi over 6. All right, so this is going to move to the right. Remember the negative, so we do the opposite of this guy. So since this is negative, this is a positive move. Looks kind of like we did before, not a whole lot different. So now we are really just taking 2x minus pi over 3 and setting it equal to 0. All right, so you added, I'm sorry, that's an x. Said x and wrote pi. your pi over 3. You divide by 2. So x equals pi over 6. It's literally the same thing we have done on everything else. So now I got a pi over 6 move. So to make my life easier, I add pi over 6 to all of these. And that tells me where I'm starting. You can either do this, or you can draw two graphs, your parent graph, and then shift it pi over 6. It does not matter which one you do. So now we've got pi over 6. We have common denominator here is 12. So we got to add our multiply. So we got 12. So this is 3 12s, 3 pi over 12, 2 pi over 12. So we get 5 pi over 12. Does not reduce. This one's 6. So we need a 3. So we got 4 pi over 6, which reduces to 2 pi over 3. Here, common denominator is 12 again. So we're going to multiply by 3, by 2. So 9 pi over 12, which is going to reduce 9, 10, 11 pi over 12. And pi plus pi over 6, this is just 7 pi over 6. All right, that's where my points are. Now, nothing has changed. The 3 here are still my zeros. So those are my zeros, are my roots. Now these here, this here is my max, so it's going to be 1 times 3, which is 3. This is my min, which is going to be negative 3. Now I just got to find all these points. And we got to go by 12ths, which is absolutely awful. There are some graph paper, if you go online, that has this divided into 12ths for you. I would go get it if you can. So all of these need to be divided into 4 to get to 12, right? We're kind of doing, that's terrible. We are making like a ruler. So you got to have your 12ths on here. All right. We are only going to go to 7 pi over 6. So we're going to go here. We are starting at 0 pi over 6, which is same as 2 12ths. So I'm starting here, which makes sense because I shifted pi over 6. At pi, I'm going pi over 6, so that shifts to there. All right, now I need to get my middle, which is 2 pi over 3, which is going to take my middle, which is pi over 2, and shift it 1/6 over, which is 2 pi over 3, which is right here. Okay, I got my 3 zeros. Now I need to go to 5 pi over 12, which is 3. So 5 pi over 12 is 3. And now we're going to go to 11 pi over 12, which is just under pi, and that's going to go down to negative 3. And there's my shift and my amplitude, all in one graph. So if you look, everything moved this way, pi over 6, from where my zeros would have been. All right, and then we went an amplitude of 3 up and down. Okay, I think it's your turn to give this a shot. Good luck. All right, when you look at this here, you should add an amplitude of pi, or 4, I'm sorry. 2 waves and 1 pi, and 2 pi. So I have 2 pi divided by 2, which gives me pi, divided by 4 happens every 4th unit. But now we got to figure out my phase shift. So we took this equal to 0, subtracted your 2 pi over 3, divided by 2, and you have a negative pi over 3. Add negative pi over 3 to your critical points. You add a negative pi over 3, so your 0 moved to negative pi over 3. Your pi moved to 2 pi. And in the very center, we had pi over 6. Now, we need to do the negative pi over 12 was up to 4. So here to 4. And then 7 pi over 6 was down to negative 4. I hope you did a good job. All right, same thing here, except now we're adding a shift to it. So they take the exact same graph we just did, and negative 2 means we move up or down. This time we just move it down 2. So nothing exciting. So this entire graph that we have here, I'm going to go up I'm going to move the whole thing down too. Draw it in red. So now instead of everything dealing over the x-axis, it now goes around -2. So your zeros are now at the -2, here, here, and here. Instead of going up to 4, you drop that down to -2, you drop that down -2 because you're dealing from this axis. So from this axis, you have to go 4 up from -2 and 4 down from -2. So it just literally shifted it down to the entire blue. Okay, if you want to do it mathematically, you subtract 2 from the y's, the y values. All right, this is just reminding you what everything does. A is an amplitude. B is how you find your period. Bx minus c is your phase shift. D is your vertical shift up and down. So here your amplitude is 3. You take 2 pi divided by 2, and you get your period of pi. You take 2x minus pi over 3, set it equal to 0, and you will get pi over 6. And 4 is your vertical shift, and it's going to go up this time. So we would be up to 4. Get this on here. Should probably do all this math over here. So we are starting at period of pi. So we're going to do pi over 4. So now I'm going to go 0, pi over 4, pi over 2, 3 pi over 4, pi. Add your shift of pi over 6 to everybody. And remember where your zeros are now. So when you add your pi over 6, you get pi over 6. Common denominator here was 12. Common denominator here was 6. 4 pi over 6, which is 2 pi over 3. Common denominator here was 12. So we got 3 into 11 pi over 12. And then we also have 7 pi over 6. Okay, there's our shifts. Okay, now it says we need to move phase shift everything up 4. So first of all, our amplitude, you would have had, of course, this would have been 0, 0, 0. This one would have been 3, and this would have been -3. Now your phase shift says you add 4 to all of these. So these new points are 4, 7, 4, 1, 4. So you're starting from 4. You're graphing in pi over 6, which is, here's pi. Let's go down to the bottom. So here's pi. We need our 12ths again. So we're going to be at, let's see where we're at here. So we go pi over 6 is my 0, or our 4 this time. 2 pi over 3 is my 0, or my 4, since I added 4. 1 past pi is my 0 or my 4. Halfway in between, we're going to go an amplitude of 3, so we need to move up 3 and mark my graph. And amplitude of -3, so we go down 3 from 4, and we are at 1. Then we draw in our sine graph. Okay, I hope you did a good job. Cosine is identical to sine. The only thing different is how you unravel it. So now I need to look at the x values on your chart. So when you look at your x value, so your first point is 1, 0, right? So your x value is 1. So sine starts at 1. Now look at every 90. So the first pi over 2 is 0. Pi is now -1. 3 pi over 2 is 0. And 2 pi is 1. Drawing your curve. If you notice, your cosine and your sine are complementary, right? So that means it's just a 90-degree shift of your sine. It is the exact same wave, shifted 90 degrees. Again, it is even because positive and negative give you the same number. Here we go. It starts the same with your pi over 1/4 period, 1/2 period, 3 period. There's nothing different. So it went from 0, pi over 2 or 90, pi 180, 3 pi over 2 or 270, 2 pi was 180, and we graphed in our dots. Okay, this is just telling you that it is a period graph, that it will oscillate, and phase shift to 90 means it moves this one here to the left 90 is going to give you your sine wave. It could actually move. So here we go. So now this is identical to the sine. There's nothing different. So we're only going to do one example. So first we look at 3 pi over 2. So it's going to go up 1.5. 2 pi divided by 2 is going to give you pi. So now we divide that by 4. So we still have 0. Pi over 4, pi over 2, 3 pi over 4, and pi, nothing different. We have a shift of pi, so we can take this here, set it over. It's going to shift negative pi over 2, so we got to subtract this. So now we have got negative pi over 2 minus pi over 2, so we're shifting 90 is going to be a negative pi over 4, subtract pi over 2 and you get 0, subtract pi over 2 and you get 1 pi over 4, subtract pi over 2 and you get pi over 2. Okay, now we're going to go down 1, so we're going to have a vertical shift down 1, so instead of being at, so this would have been, this is where your differences are, I'm sorry. This is cosine, so your first one would have been a positive 1. Your middle would be your negative 1, and your last number would be a positive 1. This time your intercepts are your zeros are in the middle. You have 0 and 0. Okay, but now I have a stretch or a amplitude of 3/2. So this here actually goes up to multiply times 3/2. So this goes up to 3/2, this goes down 3/2, and this goes up 3/2. I'm going to graph this because we've done a lot. So now when we go here, we go negative pi over 2, which is right in the middle, and that is going to be a positive 1.5 because we stretched it. All right, when we go to 0, we're going to get 0. When we go to, I'm sorry, negative pi over 4, if I can get it there. There we go. So negative pi over 4, which is here, is your 0. You're going to get at 0 a negative 1/2, 1.5 or 3/2. At pi over 4, you're going to be at 0 again. And then at pi over 2, we're going to be back up to 1/2. So this is my compression and stretch amplitude without any movement. Now I need to move it down negative 1. So everybody moves down here. So everybody goes down 1. And down 1. And this is your cosine graph. Of course, you could have added 1 or subtracted 1 from all of these to get where you needed to be, to get your point. Okay, pause and try yours. Let's see how you're doing. Okay, this one had a little bit of everything. I hope you did well. First thing you should recognize was your amplitude was 1/2. Your period, you took 2 pi over 4. 2 pi divided by 4, you got pi over 2. So then you had to take pi over 2 times 1/4 to get your critical values. Your phase shift was 4x minus pi equal to 0. So your shift is pi over 4. And the plus 1 is a vertical up 1. All right, I did everything down here in one little thing to make sure everybody was doing all right. So we did 0, pi over 8, pi over 4, 3 pi over 8. Okay, this was my period, correct? I had a shift of pi over 4, so we added pi over 4 to this, giving me my final x value over here. Pi over 4, 3 pi over 8, pi over 2, 5 pi over 8, 3 pi over 4. Now the y values start at 1, 0, negative 1, 0, 1. We have to multiply by that by 1/2, which is your amplitude. Well, after you multiply by 1/2, you got to add 1 for your vertical shift. So this is your amplitude, and this is your vertical. Right over here, this is your period, and then this is your phase shift. Ending up at, this should have been 1 1/2. It does not, like erased. 1 1/2 are 3 halves, 1, 1 1/2, 1, and 3 halves. So now I just graph all those points. The first thing I would put on my graph is your new center. All right, we're going to go to pi over 4. Here's pi over 2, pi over 4, 3 pi over 4. Okay, so we start at pi over 4, and that goes up to 1, and then a stretch of a half, so it's here. All right, our next one is 3 pi over 8, so 3 pi over 8 is roughly here. And that's going to go down up to 1 at your 0. It's very hard to graph. Okay, your next one is pi over 2, which is halfway, and that one there is going to go up to a half because we're a half below our axis. All right, we know we're going to end up at 5 pi over 8, so it's over a half. That's at my 0 again. And then we're going to end up at 3 pi over 4, which is roughly here. And that's going to end up at my 1 1/2 again. Okay, I hope you did a good job. Had a really little cosine wave that time. Okay, periodic behavior. This is just showing that this actually happens in real life. Okay, we are 30 degrees north of the equator. We have a minimum of 10 hours of daylight in December and a max of 14 hours in June. Okay, what that tells us is if we go through here, we have 10 and 14. Well, the middle is where my shift is. So I take 10 plus 14, and you get 24. So if you add these, you're finding the middle. So 10 plus 14 divided by 2 tells me that I have 24 over 2, which is 12. So I'm going to have a shift of 12. It's going to go up to 12 when we're actually doing this. Now it says hours of daylight. It's going to be a sine wave because it gave it to us in our equation. And December is low and June is high. Okay, so when I'm looking at this, December is low and June is high. Well, if I start this without any movement, let's just look what this looks like. We go here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is December. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is June, right? It says December low and June is high. But if I graph this just as a sine wave, this is the middle, this is December, and this is January. It goes, okay, this would actually be at 12. It's going to go up to 2 and down to 2. So in the middle, 4 and 6 is 3, so that would go up to 2, down to 2, and this is what my wave looks like without any shift. Well, if that's true, both my December and my June are my zeros. They are not my lows and my highs. I need December to be low, so I need to shift this direction 3, and June to be high, which means I need to shift this way, 3. So we're good. I need a shift of 3 is what that means. So I have an amplitude of 2, because I know I have to go 2 up and 2 down from 12 to get to 10 and 14. I know the middle of my cycle equals 12, or December. So I go here and I have 12 is what my cycle can be. I know that that's 2 pi over b, so I just calculate b. Multiply by b, divide by 2, and b is pi over 6. So that one's not too bad. So far I got pi over 6. I know my shift is 3. I know my amplitude is 6. Now we need to calculate my actual phase shift. So I got 2, I got pi over 6. That's coming from my 12 months. Now I need to calculate my phase shift. Well, I know that's C over B. I know that's 3 from over here. So I just calculate out what that actually is. I know B is pi over 6 from up here. So I plug that in, multiply by pi over 6, which is pi over 2, and that is my phase shift. 12 is where I went up to. Remember? Started at 12. It was my median. So kind of interesting. I hope you have fun with those. Good luck, and I hope you do on your homework, and I'm sorry for the long video. I hope you paused it a few times.